Good morning, everybody. So what you're going to need for today and also for the rest of this week, make sure you have your 6 parent functions sheet out in front of you for those 6 trig functions, because what we're going to do every unit, I think you've kind of figured out the pattern, is we start by doing some algebraic manipulation and how does it apply and what's important and special about different kinds of functions, and then we start getting to the graphing part. Well, we got to the graphing part last week, and I asked you guys to make your parent functions as to what that base function looks like. So today we're going to talk about 2 different things that can impact that graph. The first one is the amplitude, and the amplitude is when there's a number in front, okay? So basically all the amplitude is going to do is change the range. So for example, sine of x typically goes up to 1 and down to -1 if you look at your parent functions, right? That's the highest point it hits and the lowest point it hits. So if I put a 2 in the front, instead of hitting 1 and 1, now it's going to hit 2 and -2. So let's look at some examples so I can show you what I mean. Okay, so here's the graph of sine of x, right? We start at 0, 0, and it goes up to 1, and it kind of goes around, and we talked about how the period is a length of 2 pi. That's a full cycle of that part of the graph. So what happens when you change it to 2? Well, notice how it's still at 0, 0, still at pi comma 0, still at 2 pi comma 0. That period, that full cycle, is still 2 pi. The only thing that changed is instead of going up to a value of 1 on the y-axis and -1 on the y-axis, now it's going up to 2 and -2. Okay, so for example, what do you think would happen if we changed it to 1/2 or to 3? Same thing. Notice how 0, 0, pi comma 0, 2 pi comma 0. Still all points. The only thing that changed was this one's going up to 1/2 and -1/2, and this one's going up to 3 and -3, okay? So my recommendation would be to start with the points that you know are solid based on your parent function, and all that's changing is how far out these points, kind of like the top and bottom of the hills, basically, or if you want to call them your minimum and maximum, essentially, right? That's what gets stretched. Okay, so just a quick note, does this happen with cosine as well? Of course. So here's the parent function. Notice how pi over 2 comma 0, 3 pi over 2 comma 0, those are still points. That hasn't changed. The only thing that changed is instead of going up to 1 and -1, we're going up to 2 and -2 because of the 2 in the front, okay? So keep that in mind. You won't see these ones for tangent very often because there is no maximum point when you're graphing tangent, right? If you have tangent in front of you, it kind of looks something like this. So you typically don't see a number in the front for tangent, at least for right now. So don't worry about that. It's usually just sine and cosine. Okay, so the other stretch we need to talk about is if there's a number with the x. So again, let's look at sine of x, okay? Still those same 3 points from the parent function. The period is still 2 pi, okay? But now notice, what if we put the 2 with the x, or with the argument inside of the function, okay? Now all of a sudden our points are totally different. Here's essentially what I would like you to think about when you're doing this part. If there's a b value, so I'm calling this guy a b value because the amplitude, it kind of makes me think of a. So for example, if you want an example, I'm kind of thinking of it this way, okay, where a is your amplitude, the thing that stretches your range, and b is what I'm talking about right here. If there's a b value in front of the argument x, divide the original period by that value to get the new one. Okay, so for example, in sine of x, the original period was 2 pi, right? So if I do 2 pi, and I divide by the number that was in front of x, which in this case is 2. That means that the period is now pi. So what that means is it still starts at 0, 0, but a full cycle ends at pi instead of 2 pi like it did up here. So if you already know that it should have ended at 2 pi, it's almost like you're cutting it in half, right? Saying, okay, so here's 1, 0, 0, here's the other, and if this has to be a full cycle and it's symmetrical essentially, oh, okay, then that must go through pi over 2 now, okay? So it kind of shrinks it a little bit. So if you had to put a 1/2 in the front, it's going to stretch it out more, right? So if your period is 2 pi and the number in front is 1/2, here's what's going to be a little tricky. You're going to have to do copy dot flip, or keep change flip. You know, a lot of you guys have something different. So that means the period would then be 4 pi. So it'd be much more stretched out, okay? So here's a couple examples, right? Here's 1/2 pi that I was just talking about. Sine is originally a period of 2 pi. So if we're dividing by that b value that's in the front, it turns into 4 pi. Now notice how 4 pi is that full cycle that goes all the way across, okay? Same thing, so here's a graph of cosine. There's your parent function for cosine. Notice how the period is from 0 to 2 pi. That makes a full cycle. So same thing, you're still at 0, 1, okay? And the only thing that's changing is instead of 2 pi being your period, now because of we put a 3 in the front, my period's going to be 2/3 pi. So this is where it starts. 2/3 pi needs to be where it ends. Now this one's a little bit trickier when you're looking at the graph, like where exactly is 2/3? Well, you can see 2/3 right about here. And here's my ask. It doesn't have to be perfect, okay? It doesn't have to be like, oh, where exactly is 2 pi over 3? It's more so as long as you know what it's doing in those shifts, and you can at least figure out maybe the first couple points. That's the rest of it, you can kind of just go off of the answer key. Okay, so last thing I want to talk about is tangent. So tangent, like I said, you're usually never going to see a number in the front because it doesn't actually change the look of the graph very much, but you will see a number inside, and it's still the same exact thing. However, the parent function for tangent has a period of just pi. So if I put a 2 in the front, now my period is pi over 2, which means every pi over 2, it should start repeating, okay? So remember that it's going to kind of change a little bit. So just a reminder, the original period for sine and cosine for the original parent function is 2 pi, and for tangent, it's just pi. So when you have that b value in the front, in the argument, you're just doing the period divided by that b value to get the new period. Okay, so let's look at a couple examples. What's going to happen is you're going to have an assignment that I give you guys today that won't be due till tomorrow. So you'll have the rest of your time today, spend maybe, I don't know, 30 minutes on it at most, and then you'll have the full day tomorrow to finish it up. So for example, sine, right, starts at 0, 0, and the period is 2 pi. Well, 2 pi, notice how everything's in degrees. So I say, okay, well, 2 pi is the same thing as 360 degrees. So I know that's going to be my period. And all I'm messing with is the amplitude, which means instead of going up to 1, it's going to go up to 2. Okay, so my parent function, so this should be the halfway point basically, right? And it should go up to 2. It goes up first and then down next. The only thing I'm not sure of is I might be screwing that up with cosine, but I think sine was the one with 0, 0. I don't have it right in front of me. Oh, yep, it was. Okay, cool. So you'll notice how it's 0, 0, right? Still has a period of 2 pi or 360 degrees. Here's the halfway point, and the only difference is instead of going up to 1 and -1, it went up to 2 and -2. Same thing with this guy with the 1/2 in the front. There's still a point at 0, 0. There's still a point at 360. And that middle point at 180. It's just instead of going up to 1 and -1, you're going up to 1/2 and -1/2 to kind of complete that cycle. Okay, so let's do a couple where, what about the ones in the middle? So this guy, for example. So cosine typically starts at 0, 1. And it has a full cycle of 2 pi, right? So 2 pi is right here at 360. That's where it normally is at. So what I like to do is actually kind of pinpoint where it normally is and go from there. So then we say, okay, but there's a 4 in the front. Well, typically the period is 2 pi. So now I'm going to divide by 4. So that means my period is pi over 2. So instead of this point being right here, it's going to be at 180. And I know it's going to kind of drop right around here and then come back up. Okay, if you can at least get that little piece, you can kind of fill in the rest and just kind of fudge it a little bit. This is the most important part for me. So if we look at the answer key, right, it starts at 0, 1, and it makes that full period at pi over 2, which was 90 degrees. So I apologize. I said 180 on the last slide. I don't have the radians and degrees right in front of me, so that was my bad. Okay, now here's the only part that might trip you up is when you have something like this. Just think of this like it's written like that. Okay, so when you do the period divided by the number in the front, don't forget you have to copy dot flip. So now the period's actually going to be 4 pi. Okay, so just keep that in mind as you're doing it. If that's messing you up, obviously with the degrees, you can either change the degrees on the worksheet to be in terms of radians, or you can change these guys and say, oh, okay, 4 pi is the same thing as 720 degrees. Okay, so it's up to you how you want to do that. Last thing I want to recommend is you are going to have a few at the end of your assignment today that are both. Okay, so here's what I would recommend. I would actually start with shrinking it, like start with the 4, okay? So sine is typically 2 pi. So 2 pi divided by that 4. The new period is going to be pi over 2, which, I'm not going to screw it up this time, is 90 degrees. So typically sine starts at 0, 0, which means at 90 degrees, that will be the other 0, 0, and that's where it goes, okay? So if that's the only thing I had, I would make my curve and I'd be good. But because of the 2, that means when I go to do this, I want to make sure I go up to 2 and down to -2. So it's actually going to look something like that. Okay, and you can kind of just figure out the rest. So the whole idea, you guys, is when you're doing this, figure out the middle stuff first, figure out what's your new period length, right? So in this case, it was 90 degrees or pi over 2. Then worry about how high or how low it goes. Okay, so stop by, see me for office hours if you need some additional help or if you're working through the homework. I will assign the homework today, so work on it for, I don't know, 20, 30 minutes today, and then leave it for now and come back to it tomorrow and finish it up and get that submitted. As always, let me know how I can help. Stop by for office hours so I can assist a little bit more. But otherwise, we're going to be working on homework number 2.